Okay, so we're going to look at the present value of an annuity. So the present value formula is written like this. This is the present value. R stands for regular payments. If you're using a graphing calculator, sometimes they write regular payments as PMT. Maybe it's like payments every term. I don't quite know what those stand for, but that's what it would be, a regular payment. And our equation is 1 subtract 1 plus I being the interest rate per compound period, to the power of negative n all over I. So in order to calculate I, R, lowercase r, is our actual interest rate. So maybe I should write that in here. I'll write that in purple. R is interest rate, while C is our compound period. Does that make sense?
Yeah.
Okay. And period. And then YR is years times C again, which is compound period. And that's how we calculate our N. N is the number of periods over the life of the annuity. So we've been given this question. We want a scholarship fund to pay $100 a year for the next 10 years. So maybe the top student in the course gets $100. We are able to invest our money at 5% or 5.5% per annum compounded monthly. How much should we invest now in order to provide this annuity? So in the end, we need to be able to pay out $100 every single year, okay? And our compound period here is going to change a little. Oh, you know what? I'm going to change this question. We're going to keep the compound period yearly just because with annuities, our regular payments have to be at the same time as our compound periods, okay? So we could rework this question, but for simplicity's sake, we'll just do it compounded annually, okay, just to make this a little easier. And then we can talk about how we could have done it monthly after and how we could kind of change the question, okay? But we'll start simple. So what that means is we have to figure out what's important here. And what we need to figure out what's important is we need to find out what our interest rate is, which we have. It's 5.5%. The compound period we just said is annually, okay? So our R is, and we change this into a decimal, 0.055. Our C is once a year, so it's just the number 1, okay? Our number of years, how long do we expect to do this for?
10.
10 years. So our YR is going to be 10. Okay, so we found a whole bunch of information. What about our PMT, or our regular payments? What are our regular payments? Every year, how much are we paying out? $100, yeah. So our uppercase R, or PMT, is equal to $100, okay? So we'll rewrite our formula again. Present value, that's how much we need to invest now, which we're trying to figure out, is equal to R. Okay, we have our R. 1 subtract 1 minus I. So we need to calculate for I. And we said I was interest rate, which is R, so 0.055, divided by compound period, which is 1. So when we divide any number by 1, it ends up being that number. Okay, so we have our I. To the power of negative n, or in our case, we'll just work with n. I'll write in blue. N is equal to years, which is 10, times compound period, which is 1 again. It ends up just being 10. So because our compound period was once a year, it didn't change those numbers. But had it been any other amount, it would have changed what we'd be putting in for I. And then again, here's our I. So we plug in our numbers. It's pretty straightforward, this part. PV is equal to regular payments, which is 100. 1 minus 1 subtract our I, which is 0.055, to the power of negative, well, our n value is 10, okay, divided by 0.055. Okay, so the goal here is to isolate for PV, which we've done. PV is on the left side. How much do we have to invest right now? We're just going to run this through our calculator very quickly. And we'll kind of do it step by step. PV is equal to 100. Okay. First, we're going to deal with those brackets. So 1 subtract this value. Bring out our calculator. 1 subtract 0.055. 0.945. So 0.945 to the power of negative 10. So that number needs to go to the power of negative 10 first, all divided by 0.055. Okay. So the next thing we have to do is our exponent. Let's see if we can do that very nicely here. Take that answer, and we put it to the power of, and I have to put it in brackets probably, negative 10. Okay. Negative power is going to change our number a little. So here we go. We got 1.76-ish. Okay. I'm going to write this in step by step. You might have been able to type everything directly into your calculator, but I want us to see the process one by one. So we've just equated this part now. PV. We still haven't done anything else with anything else. 100. 1 subtract, and the number we got was 1.76. 7606, we'll say. So kind of kept it going. All divided by 0.055. Okay, so let's try to do this all in one step here. I'm going to take the first numbers and subtract them. Okay, so I got to this part and I stopped because I had realized I'm going to get to an answer that's wrong. So I've made an error somewhere back here, which is fine. And I'm going to go check. And what it is my original formula. This should say plus. And I've written as negative, and I kind of just followed. Actually, I wrote it as plus here, and I wrote it as negative here, and that completely messed up everything we were doing. So we're going to have to change a couple things. What that means is this is going to be 1 plus that number. So when we get to this step, this is not going to be a number less than 1. It'll be greater than 1. So that's going to change for us. Okay, in fact, it's going to be 1.055 to the power of negative 10. Luckily, we broke this into steps, so this number's off by a little. Okay, I knew there was some silly area. We should have got a number a little less than 1, not a number greater than 1. So when I put that to the power of 10, 1.055 to the power of negative 10. There we go. 0.5854, let's say. 854. Okay, so a mistake on my part. Okay, so luckily we corrected that. Now we're going to try to do this all in one step like I said before. So 1 subtract 0.5854 is equal to, and then going to divide it right away, divided by 0.055. Okay. And then the very last step would be to multiply by 100. So maybe I'll write this in, 7538. So I just finished the bracket. I equated that. So PV is equal to 100 times 538, I think. 5381. 5381. Now, I could use a calculator for this, but I know if I multiply anything by 100, all I'm doing is moving the decimal 2 places. So our present value will equal $753.81. So let's try to make sense of this. We're going to pay out $100 for how many years?
10.
Yeah, once a year, right? So 100 times 10 gives us $1,000. So we're going to pay out $1,000, but we only have to invest $750. That's pretty good. We're investing less money than we're actually paying out. So we're earning interest. And if they were to ever ask you how much interest did this annuity earn, we would take this total, 1,000, and we'd subtract what we got as the present value, which is 75381. Okay, and this is 0.00. Okay, so this is going a little beyond of what we needed to do, but it's good information. We subtract the 2. Okay, and these all become 9s. And remember our subtraction. And this becomes 91.642. So we earned $246.19 in interest over those 10 years in this annuity.